We're going to be talking about Splunk in general because that's always the first question we get when someone talks to us is, what is Splunk? So hopefully we'll solve that mystery today for you guys. And then we'll take some time, hopefully as much time as possible, on giving you a demo and showing you what we're doing from Zen Desktop perspective. We also have stuff for Zen App, generic server virtualization that we'll probably go through. So let me go ahead and click here. So the agenda is pretty simple. We're going to talk about what is Splunk. We're going to talk about what a Splunk App is, because you're going to hear that term a lot, Splunk App, and understanding that a Splunk App is not a piece of code or anything like that. It's just really a set of dashboards and configuration. It'll make it a lot easier to understand what we're doing and how this is really useful to you guys, because that's what's important. And then we're going to talk about the Splunk App for Zen Desktop, Zen App, NetScaler, and server virtualization. So let's start out with what is Splunk. One thing that, I mean, y'all have been, most of you guys I would guess have probably been in IT for a number of years, 5+ years, I would guess, majority of you. You've been around long enough to know that everything that we do on a day-to-day basis generates data. It could be log files, it could be syslog, it could be Windows event logs, it could be performance logs. There's log files coming out the yin-yang all over the place, right? We have routers, firewall switches, they all do logs. We have Windows servers and Linux servers and Macs. Everything outputs what we call machine data, which is data that's driven by machines, not data driven by users. So all of that data comes from all different parts of your business. It comes from your enterprise servers. It comes from business analytics programs, stuff like Salesforce. All of the line of business applications that you have, everything generates logs and generates data. And pretty much any time that you've had a problem, probably in the past 10, 15 years in IT, generally to fix that problem, you always had the data that you needed. You just had to go search for the data, right? You had to go find out, okay, where is this log file at? Where is this log file at? Where in the link in the chain is it broke, right? So the data has always been there, but there's always been this really painful experience of trying to go find that data, right? And that was when Splunk was first designed and built. That was the kind of the problem we were trying to solve, is that, hey, we have all this machine data. Instead of just letting it go off into Never Never Land, let's collect it all, and then we can provide a data engine that lets you correlate and consolidate and do all the stuff that you need to do to quickly find answers to problems that you have. So this is just one of those architecture slides that shows you all the wonderful things we collect data from. The other thing is that this is probably one of the biggest, fastest growing parts of digital data. Is machine data. As data centers grow, cloud becomes bigger, and there's more stuff going on. There's a lot more logs. The data just keeps getting bigger and bigger and bigger, and we've not really, like I said, until Splunk, and there's other companies doing it now too, there was no way to really capture that data. So it was kind of like snowballing. It's like example generated continuously by websites, and it's how we can determine what users are doing, where they're going, what are they doing, how they're using stuff, all of that kind of good stuff. And this is really valuable data. And what we want to do is consolidate that data into one spot and then provide a reporting engine to allow you to get data out of there. So this is kind of like your typical, this is actually not our typical one. Our typical one is like a database admin type thing, but I want to make it Citrix oriented. But this is typically what life in the trenches is for a Zen App or Zen Desktop guy. You get the service desk guy gets a call, logs the call, the user says it's not working, and then we proceed to find out over the next hour or two what it is and how we can fix it. The first thing that the service desk guy normally does is he calls the desktop group and it says, desktop guy is going to say, you know what, this is a virtual machine, not my problem, go talk to somebody else. and then or go talk to Citrix. Then they go to the Citrix guy, and the Citrix guy says, you know what, my DDCs, my web interfaces, my VDA, they all look good. Go talk to networking. It's always networking. Always networking. So the call talks to the networking guy. The networking guy says, you know what, I don't see any drop packets. Must be working. And you know what? Funny enough, you're the only one complaining. So my network has got to be working perfectly. So go talk to the VM guys, because you know they suck. So they go to the virtualization group, and the guy's like, hey, look, the power's on. There's no magic here. It's working, right? So go talk to the storage group. And the storage group's like, yeah, it looks like there's too much traffic on this LUN. Let's move them to a different LUN. Problem solved, right? The thing is it took like a lot of time to get to this point. But once we got to this point, how long did it take to fix the problem? Doesn't take very long at all, right? And that's typically the way it works is you spend hours trying to figure out what the problem is, and you spend like 5 minutes fixing the problem. And the idea is if we had all of this data, or the data that the storage is generating, the virtualization hypervisor stuff is doing, the networking stuff is doing, if we had all the data from the Citrix DDCs, the web interfaces, all that stuff in one spot, in the desktop group, all the event logs, all the performance data from the virtual machine, if we had all that in one spot, the help desk guy could have went to one page and said, put in a username, and it could have like little red, yellow, green lights. Oh, looks like a storage problem. Let me call the storage team, and bypass this whole process, right? And the user's time to resolution is a few minutes as opposed to hours, right? That's ideally what we would like to get done. So that's basically showing you, hey, we did a search, we figured out what the problem was. Life is good. So that's the part of Splunk that would make you happy. That makes your life easier. It lets you provide an easy way for your help desk and people that you support get an answer easier. There's a lot more behind Splunk. Because we have all the data, we really have all the answers that your CEO, your executives, your reporting structure, your business analyst, all the data that they want about the stuff that you're doing, the stuff that makes you money, all that data is there as well. So you can really create, to use lovely buzzwords because everyone loves those, operational intelligence. You can really provide operational intelligence to your entire product line, your entire business, from IT, operations, all the way to CEO type stuff, because we can build reports. You can say, you know, an example is you may care that a server went down. So like say a Zen App server crashes. It could have been because of storage, could have been because of the hypervisor, could have been for a variety of reasons. But for some reason, the Zen App server crashed. And there was 50 users on there, right? That is, it's a number you can say. So when your manager comes to you and say, we just lost 50 users. What was the impact, right? What did that cost us? Like what was the negative impact of that, right? Because that 50 user crash or that server crash could have possibly been saved by having another server, or could have been saved by having high availability on the SAN or something that your business said, you know what, it's not worth it. But you had no concrete data to say, this is why, this is how much this is going to cost. If we lose this server, this is how much it costs us, right? Splunk can provide you that value because we have all those data points. We can say, well, you know what, when this user's not working, this is how much money we lose, right? And so you multiply that by 50, and then you figure out, so when this server goes down, it costs us, you know, $45,000 or something like that, right? And then you could say, you know what, if we would have just spent, you know, $20,000 on this NAS upgrade or SAN upgrade, we wouldn't have lost that money. So it becomes easy for you to start proving why you should buy more hardware, or why you should increase your capacity or whatever you need. So that's pretty much what this slide's supposed to be saying. So the other cool core thing to understand about machine data is that it's not structured by nature, right? Machine data does not squeeze well into a relational database, right? It's not field property driven. It's normally, it's never the same. It's inflexible. It just doesn't work like that. So I mean, relational database, SQL, for example, right? It's a really powerful database. It's really useful. It's not evil. It's not bad. But it doesn't fit everything. Have a hard time convincing Citrix that because they shove everything in SQL, regardless if it needs to be there or not. But it's one of those things where, you know, if you're a carpenter, you know, everything you see is a nail, or if you're a hammer, everything you see is a nail. It's just, there's certain situations where a relational database doesn't fit. And when we talk about machine data, this is one of those scenarios. If you start calculating out what machine data means to you and to your business, you're not going to see values of, you know, 1 gigabyte a day or 2 gigabytes a day, right? Most companies are seeing tens to hundreds and hundreds of gigabytes a day of data that's coming in that you have to collect, right? SQL is good at storing big, large swaths of data, but if you were to try to get, you know, 400 or 500 gigs of data a day, chop it up, shove it in a SQL database, you would have to have a really, really massive hardware set to be able to support that. We prefer, the way we do it is we use a MapReduce index. We actually don't even have a database because machine data is time series unstructured data. So it's generally, when you're talking about machine data, the most important value in that machine data is when it happened, right? So our index is time-based. It's generated by all IT systems, so it's obviously going to be highly diverse formats. You might have something in XML, you may have something in plain text, you may have a syslog message that's really crap, looks like crap. You have some other syslog messages that they try to do a good job of making human readable. Even if you just pick Citrix or just pick VMware and look at the log files from their different products, they look astronomically different, right? They don't look the same. So all of these things for machine data make something like in a relational database just basically a no-go to have a fast, efficient way of accessing that data. And unfortunately, well, fortunately for Splunk, unfortunately for a lot of our competitors, that's the route they took, right? A lot of our competitors will go down and like, oh, well, we need a database, let's go get SQL, because that's what everybody uses. Without thinking about, you know, the idea behind what the data that they're trying to collect, it just doesn't fit that mold. The Splunk Mission, we want to collect and index any machine data. It doesn't matter where it comes from. This is just one of those slides that kind of says all that. Log files, configs, messages, traps, alerts, metrics, scripts. That's one of the things that we do that's really useful as well, is that we can take output or input from scripts. So if you have some product that you wrote that has a REST API, or you have a product that you wrote that you use that doesn't have a log file that's easily accessible, you can write a script, connect to that device, dump all the data that you want, and put it into Splunk. An example of that is how we do the Zen App stuff. So Zen App, this has farms, it's got zones, it's got all this information that we want to collect. But there's no place for me to point Splunk and say, hey, go get this information. So what we did is we wrote scripts to dump all that information from PowerShell and then get that data that we dumped from PowerShell and put it into Splunk. Again, because of the way that Splunk is, we scale really, really large. We have many customers that do multiple terabytes of data a day. I think our biggest customer right now is 100 terabytes a day. And that's text, right? A lot of data, right? We don't have any upfront schema. We can change stuff on the fly. We do, when we look at data, when we pull data in, we do what we call real-time field extraction, which means that we don't pull out the field value pairs on index time. We don't index those fields. We only index basically 4 pieces of data: the host, where the data came from, when it was collected, and then 2 pieces of information that clarify the source of the data, source type, and that kind of stuff. Because of that's the case, all the fields that you see, username, like when we start looking at the apps, you'll see server name and username and all these different fields. All of that field was extracted from the data the time that I press go on the search. It wasn't done prior. Does that make sense? And we never change the data, right? So the other good thing about this is it's not just, it isn't just visualizing the data. It's not just making it pretty, although that's what we do really well. It lets you provide context when something breaks. So there's a lot of products out there. If you were to build a monitoring product on top of Splunk, you could compete pretty well with any monitoring product on the planet. But one thing you would have just straight off out of the box is the ability to troubleshoot. So most monitoring, they'll give you a little red tick or a little red box or a little red flicker thing saying, hey, something's broke. But normally when that happens, what's the first thing you have to do? You have to go find a log file. You have to go find out what machine was doing it. You have to go start looking and trying to figure out why that problem happened. Because we collect the data raw, we don't ever change that data, we have the context of the alert at all times. So, end-to-end integrated solution. I mean, that's the plan, is to have the ability to collect the data, store the data, create searches, all that kind of good stuff, and then provide not only IT operational views, but also provide business analytical views and stuff like that. This again, marketecture slides. Splunk. If you were to break Splunk down, the other cool thing about Splunk is that it's pretty much self-contained. It doesn't require any infrastructure other than Splunk. So if you were to, if you wanted to have a Splunk infrastructure at your office, you could just go home, go to your office, pick one of 12 or 15 different platforms. Windows, pretty much every version of Windows from XP and above use the 32-bit and 64-bit. Most versions of Linux, Mac, OS X, 5 and 6. And then we do AIX and Sun, Solaris, yeah. So we support all those platforms. So you pick, whatever OS you're most comfortable with. You install Splunk, and the cool thing is that Splunk works exactly the same on all the different platforms. So if once you understand how Splunk works, you can go to any platform or any Splunk instance and pretty much very easily get understanding of what's going on. The folder structure is exactly the same on all the different platforms. So Splunk has basically 4 primary functions. We have a searching and reporting. That's what we call the search head. This is the pretty interface that you see. We have an indexing and search services. This is the guy this is the workhorse. This is the guy that collects all the data and sits there and crunches it and puts it in the index and does some of the searching when a search request is made. We have what we call a deployment server, and when we talk about Splunk apps, this will make a little bit more sense. But the point of the deployment server is to get what we call a Splunk app and get it out to what we call a universal forwarder, which is the last guy here. And the universal forwarder is just a very small version of Splunk that doesn't do any indexing. It just does the data collection. And then, so it does the data collection and sends that data up to an indexer. An example would be for Zen Desktop, we have to have, for lack of a better term, an agent on the VDA to be able to collect data, the performance Windows logs, performance logs, because you can't pull that data. It just doesn't work, right? So we have to collect it locally and then send that up to the indexer. That's what the universal forwarder does. So the deployment server is responsible for making sure that, instead of calling it an app, let's call it the configuration. So the deployment server is meant to get the configuration out to the agents so they know what to do. Does that make sense? Yeah. The important thing is that you can have all of these installed on the same machine, or they can be on different machines. It's up to you. They are very easy to break apart. So you may want to have like one search head and like 100 indexers if you have like a lot of data, or if you only have a small amount of data, maybe 1 or 2 indexers. Understanding that we're a MapReduce index, so the more indexers you throw at Splunk, the faster it gets. What does MapReduce mean? It means it's fast. No. Does everyone know what that means? Answer it. So a MapReduce index is the ability. It gives you. I don't know if I can explain it right.
MapReduce index, so basically the indexer of Splunk scales as you need scales. So an indexer for Splunk, they're going to bring me a mic. That's awesome. So we'll wait until the mic gets here. Run, quickly. Go Chelsea, run.
Chelsea.
All right, yeah, Chelsea Football Club, yay.
Oh.
So anyway, MapReduce index. So the indexer piece over here, actually if you look at some of our handouts and things, it actually has an icon of a database, and it looks like a database, but as Brendan already explained, it's not a database. So it's just an instance, and that's the indexer. So this thing will scale out almost like a grid architecture. So if you need more capacity, faster searching, whatever, you can just scale out more indexes. And you can think of it as kind of like a RAID array with disk. If you need to stripe across many sets of disk for faster read times, like RAID will do a lot faster read because there's multiple spindles to go read from. So a MapReduce index is pretty much the same thing. You scale out multiple indexes, multiple machines, and then as a search goes, it can go read from any one of those machines. So the read time to go do your searches is much increased. So RAID array, very similar to a MapReduce index in terms of Splunk. Does that make sense?
Well, I thought you were going to like get PhD on me. Anyway, anyway, back to the initial point. They can all be installed on one device, or you can separate them out. Depending on the environment, depending on how much data you're going to index, sometimes it makes a lot of sense to break off the indexer and the search head. In this particular case, the indexer is obviously IOP bound because it's writing a lot of stuff and reading a lot of stuff from disk. The search head is IO, is CPU and memory bound. Basically, this is a slide to tell you that we can scale across data centers. We can have multiple indexers. You can have indexers in multiple locations. They don't have to be in one spot. The search head can search them regardless of where they're at. To the MapReduce concept, it scales literally to terabytes a day. Effectively, I guess it's limitless in regards to how big it can go, because all you have to do is throw more hardware at it and add more indexers, and it gets bigger and faster, and that's the idea. It's very similar to the way some of your common, one of your most popular search engines works. Like when you do a search on a search engine, it doesn't just send it to like one box to get the answer, right? It sends it off to like 10,000 machines. And because all 10,000 machines are responding at the same time, you start getting millions of results immediately, as opposed to getting, where it's a serial thing, waiting for this guy to give me a million results just from one box, right? Runs across data centers, yeah. So what makes us different? Any data. So we can really, as long as it's textual data, we don't do binary data, we don't do that kind of stuff. But as long as it is textual data, we can index it and provide some value on top of it. It's completely flexible, supports basically, the way I explain it is like a lot of people say, well, are you a monitoring company? Are you a alerting company? Are you a log consolidation company? And I'm like, really not any of those things. What we are is a data search company. But because of the way that our product is designed, we can make, or you can make a monitoring product on top of Splunk that will go head-to-head with any other monitoring product on the planet, right? You can make an alerting product on top of Splunk that can go pretty much head-to-head with most alerting products. And it's the same thing with log consolidation. Those aren't our core focus. That isn't what we do. But because of what we do and how we do it, we can do each one of those components very well. And you'll see this when we talk about the Zen Desktop App and the Zen App, this stuff that we've built on top of Splunk. Those could be classified as maybe a monitoring product or alerting product or a business analytics or operational intelligence app. But core Splunk is just basically a search engine for machine data. And I think that's what makes us different. So we've talked about Splunk. When we say a Splunk app, because this gets a little confusing to people, all a Splunk app really is a set of config files. So if you go and you look at what Splunk is underneath the covers. It's a process that runs, or an executable that runs that does all the magic, all the indexing and stuff like that. And this executable uses a bunch of config files, right? It's very Unixy, right? It uses a bunch of config files to figure out how to do what it's supposed to do, right? What am I supposed to collect? Where am I supposed to put it? You know, where my indexes go? Where, you know, all the stuff that you can configure in Splunk. And if you go into the, when you go into the Splunk management interface and you start looking at all the checkboxes and the prettiness that you can do, everything in there is actually just a config file underneath. So when we talk about a Splunk app, all the Splunk app is a bunch of config files that specify the data that you should collect and where you should put that data on top, and a set of XML files. And these XML files tell you what the app should look like. So what dashboard do I put where, and what, all that kind of good stuff. So, well, yes, and to Jason's points, one thing to understand is all the Zen Desktop app that I show you, the Zen Apps app, if we get server virtualization in NetApp, not NetApp, NetScaler, all of these apps are free. You just go to, we have a community website, go to splunkbase.com and you can download them. The apps don't cost you anything. The way that Splunk is charged, or the way that we make money off of the product, is by indexing data. So the way that we charge is by how much data you index. So if you were collecting 10 gigabytes a day of data, you would buy a 10 gig license. It isn't how much we store. You could store as much as you want. It's how much that you index on a daily rate. Basically, what is your throughput? Make sense? So basically, app is a group of searches and dashboards. We have what they call a technology add-on. This would be what we like to call it a TA, because we're all lazy and we don't like to use big words. We use small words. So we have a TA. An example of a TA would be the Splunk app that I put on the VDA, or the virtual desktop agent, to tell it to collect Windows performance logs and all that kind of good stuff, right? So that's just a basic, all that is a set of configs that tells this agent over here, this is what you need to collect. It also stores searches, so the searches that you want to run. So you can have predefined searches so that you don't have to, remember to type the search over and over again. You can create a search that does what you want. You're like, really, I really like that search, and then you can save it. That's a save search. Those save searches are put in what we call an app. The dashboards, the GUI, the XML. Let's go ahead and show you what an app looks like here. All right. So this is the Splunk log on screen. All right, so this is the Splunk app for Zendesk, or one page. There's obviously multiple. If you look up here, there's multiple pages or tabs. But this is the first page that you see. Actually, this is deployment. This is the session statistics. So this is a page. It basically will tell you, in this 24-hour period, you've had 10,000 sessions, 322 users, 10 servers, and then you have top 10 users, top client IPs, top servers. This is what they call an app, right? If you actually look underneath the covers and take all the prettiness off, meaning the dashboards and all that stuff, this is the data that we actually collected, right? So we built off of this data right here, we built that dashboard. Does that make sense? And what I want to do, actually before we go into the Zen Desktop or Zen App, what I'll do is we'll go through that. I'll show you kind of the man behind the curtain, as it were. So,
yeah, as Brendan's typing this, just want to make a point that all the screens and everything that you see, well, the data that he's showing here, that's what Splunk is collecting. That's the raw data. That's the data that we never change. But all the dashboards that he's about to show you, these are pre-built out of the box, but they're built using out-of-the-box tools. So we give you the app for free, but it's really kind of an example. It's fully functional, and it's going to be great for most people. But if you see something that's almost like what you want, the app itself is really just open source. You can look at how it was done, look at the search on how it was worded, tweak a little bit, save it, and then it'll be tweaked to your environment. So there's no coding that we're doing here, as he's about to show you on the example. You can do everything that you see here on the GUI stuff, the way that the user interface looks, you can do yourself. Anybody can do themselves out of the box. There's no programming or coding or anything like this. Everything is really just an ad hoc search.
Right. So what I want to show you here is, so again, we're an index. So the first thing I'm going to do is I'm going to put in the index that I want to look at. So I'm looking for Zen App data. What I'm going to show you is I'm going to build a quick dashboard for server load and, let's say, application count. How many sessions you have in an application, right? So we know that we want to look at the Zen App index. One thing you want to know, what you'll probably want to notice here is that again, the field extractions. See, I have not at all told Splunk anything about my data. I haven't told it anything at all. In this case, it's determined that there's a property in this data set, and it's actually right here. It sees this, right? It says, you know what? That looks to me like they have a parser that looks at the data and says, this looks to me like a field value pair. So I'm going to assume that when a field value pair, this is going to be the field name and this is going to be the value. So it's determined, okay, I'm going to create a property called farm name, and I'm going to put the value of that to be XA65. Does that make sense? The reason why I'm pointing that out is because once you find out like what index you want to be in, Splunk will kind of educate you as you go on what you're looking for. So I said we wanted to do server load. So if I look at source type, can you see that? All right. So if I see source type, although I don't know if you can read these because it's itty bitty. These are the different source types that I have. And one of the source types here is XA65 server load. I know that's probably what we want to go after, right? Because I said we want to look at server load. So I can just click that, and Splunk will add that to my search. Now the data that I'm getting back is just server load. Does everyone see that?
To understand what server load is in a Zen App environment, you basically load evaluator, you go to command line, q1/load, these are the values that come back.
This is the data that we have there. It's just load equals 100 machine, blah, 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 server name, all the different fields. But this is just the raw text. This is really useful if I want to try to troubleshoot, but it's not visually pleasing to the eye. So if I want to turn this into something visually pleasing, I can do like let's say I want to do a time chart of average load by server name. Right? So I want to know what the average load of the server name is over time. Right? So it'll take a few seconds to fill out the chart. So it filled it out, all this. All of this search is being done real time. Nothing. It's not pulling anything from cache. Right? It's just pulling it as we search. Now that's a little easier to read, but it's still not pretty. Right? It's not what we want to see. But we have this little chart, what we call a chart button here. If I click that, it'll convert that into a chart. Now that, depending on how many servers you have, may or may not be visually pleasing. We can always change that to whatever we want it to be. If we want it to be a column graph, or if we want it to be a area chart, which I think is probably the best. This helps you quickly determine if there's any particular server that seems to be getting more load, so you can see patterns and stuff like that. Once I have this data, I can just do this, and I can say dashboard panel. So I want to say I like this search, I want to save the search, and I want to create a dashboard panel so that I can go to one screen, one page, and that's always there for me. So I'm going to call the search server load by time. The other thing is by default, whatever your time range, so I had here, I had show me the last 24 hours. I can say I want this to be the last 24 hours. I want it to be the last 7 days. I can change this time range to whatever I want, and it can be a range. Because right now it's negative 24 hours to now. If I want to say negative hour to now, or if I want to say negative 24 hours to negative 12 hours. So if I always want to see a 12-hour window prior to my current 12 hours, I can do that. So I'm going to create a new dashboard. I'll call it my new dashboard because I'm creative. You can specify, the other thing is that you can create these dashboards and you can share them with other people, or you can say, you know what, I did all this work, I want to save it for myself. No, you can say either share it or you can keep it private. So the reason why you might want to keep it private is if you're working on it or has private data that you don't want other people to look at, or if you just want to work on the dashboard yourself until it's tweaked to the point that you're really happy enough to share it, you can switch it at that point. But I'm confident in my abilities, so I'm going to share it straight off the bat. And then you just do finish. All right, so now if I go and click my new dashboard, I have my dashboard pop up automatically for me now. There's no data behind it. I mean, there is data behind it, but you don't see it. If anyone was to go to this page, since I shared it publicly, they would add this. So this is kind of cool, but we want to add more stuff. Oh, the other thing you can notice here is this. Once you create the dashboard and get it going, you can turn the editing of the dashboard on and off. So you can actually add and remove panels as you want to. So if you click on, it'll let you edit, and you can do stuff like edit search. You can edit the visualization, say, you know what, I really thought I liked the stack trace, but I really don't want to do the stack trace. I want to do, or I want it to be stacked, but I want it to look different. Right, I want it to look like that instead. I can change the views. The other thing is I can go back into the searches again. Let's say now I want to add another, I like pie charts. Everyone likes pie charts, right? Who doesn't like pie? I want to make a pie chart of, let's say, applications. So we're going to go back into Zen App. We're looking at source types. We want to know all the applications we want to know what applications users are using. So we're probably going to want to get session data, right? Because we want to get all the sessions and see what applications are being launched in those sessions. And then we want to say, all right, let's see stats count. So it's a Splunk command of
So this stuff that Brandon's typing here, this is the search language for Splunk. It's very similar to Unix or PowerShell, where you take a command, you pipe it to another command, you pipe it to another command. And so there is, if you get into Splunk, there's a little bit of a learning curve to learning the Splunk search language, but once you get into it, it's actually quite intuitive to be able to do these searches yourself. So, I mean, I joined Splunk in January, and I didn't know anything about Splunk, and actually, there was a little bit of learning curve to get over that, but just like any kind of scripting language. But once you get over that, it's quite easy, and it makes everything.
It helps if you spell properly.
If you spell properly, things actually work.
Does not have an idiot speller check. All right, so this is the data we want to have. This is obviously probably not going to look very good in a line chart or a stack chart. So I'm like, yeah, probably not what I want. I'm thinking, like I said, I like pie. Pie is probably a better view for that. In this particular case, not all that interesting, since it seems that our data gen is being very consistent in regards to the number of applications that get launched.
I wrote the data gen.
He wrote the data gen,
Sorry
so
about that.
sometimes you fail. Anyway, so now again I can go back into dashboard panel. I can call this my get applications by count. And again, I can change the time frames, but I'm not going to. I could either create a new dashboard, or you know what, I'm like, I already have that other dashboard. Let me go ahead and pick that. And I still want it to be a pie chart. Oh, I meant to actually go to crap. I goofed. Yeah. I know I didn't want to have to do that. You can actually, back to the thing. So we have these little things, the tabs here. These are all just what we call views. You can add, once you get the dashboard looking the way you want to do it, you can add this view to where it would be, so you would have you could add a tab up here that said My Views, or my new dashboard. But because I haven't done that, I actually, to get to the view, you actually have to go to the manager. So this is the user interface. Anyway, so this is the dashboard we just created. All right, very, very pretty, right? This will win awards on prettiness. But anyway, I just wanted to show you how easy it was to get raw text, convert that raw text into useful dashboards that you can build on top of later. With that, let's go back to before we go and show you the Zen app, the Zen Desktop, and all that kind of good stuff. Is there any questions?
Question in the back?
Oh, yay. Mm-hmm. Well, so yeah, it's a so the question is that how, because we price per gigabyte, how do you go about selling the product to a customer? I suspect you're talking about specifically for like the Zen Desktop or Zen app. All right, so in those situations, what I try to do is I measure the data. So I have my own lab. I build the lab. I get the app running in my lab, and I measure the quantity of expected data, right? So we're not collecting anything that's unexpected. So I can tell you, for example, the Zen Desktop, it ends up being about 30 megs per desktop that you collect on a daily basis. So I mean, that's kind of my job, is to make sure that I have numbers to give you, because yeah, it's not fair. It's like, hey, you should use Splunk for Zen Desktop, and how much is it going to cost me? I don't know. We'll see after you start using it. Right? That would not go over very well.
The data collection numbers, everything in Splunk is configurable. In these apps that we're talking about giving out, that they're free, they're pre-configured, but they can always be tuned. So if there's particular instances that you don't want to collect some data, like if you had some other monitoring product that was collecting perpmon data and you wanted to turn that off on Splunk, I mean, you lose a lot of functionality in the app, but you could if you wanted to keep that rate down per day.
Yeah. So you can everything that we do here. And it's important to understand that I call this the Splunk App for Zen Desktop, the Splunk App for Zen App, NetScaler, all the different products, right? It's very important to understand that I haven't done anything that you couldn't have just done on your own, right? The value add for me doing it is the fact that we went through, my groups went through the trouble of researching the data, looking at the data, seeing what's important, talking to customers, say, you know, what kind of dashboards are important to you? We've done a lot of research to provide a lot of value in the app, but there isn't anything that we've done that you couldn't have done yourself. So you could easily tweak, you can change, like you can, our performance collector, you can, we've had customers turn it up, and we had customers turn it all the way down. Like we had one customer, we were collecting performance counters for the VDA as a whole system. We were collecting performance counters every, I think, 3 minutes. We had a customer that kicked it down to 30 seconds. Like, you know, I don't care how much money it costs. But then there's other customers who's like, I don't want to spend money, right? So we can customize that completely. Yes?
How does the licensing work in that, you know, I might have a day with a big data spike, do you just drop my data so I can...
Oh, so no, that's very important. Good question. So his question was, what happens, what do you do with data spikes, and how do you do that? So Splunk will absolutely never stop indexing. It will index forever. If you have a 10 gigabyte license, you could throw a terabyte at it, and it will not stop indexing. What it will do is stop letting you search the data. So obviously, indexing the data is part of it. The other part is being able to search it. The way that it works is I think you have 5 violations in a month period. So we expect people are going to, like if you have a 10 gig license, you may go to 15 or 20 gigs every weekend, or like there's a possibility that you're going to spike. Ideally, it's best to buy that license, but I think we allow you 5 violations within a 1 month period before we disable search. And then what will happen is if we disable search, all you'll have to do is call to support, say, hey, this is what happened, reset my, you send me a reset key, they'll send you a reset license key, you do it, and then the search engine will start working again. Make sense? Yeah. Okay. So we can look at, we can do the Zen app one. Since it says Zen Desktop on the board, we'll start with the Zen Desktop.
And also, I mean, it's important to understand all this data is coming in, and so one of the cool things that actually is in the Zen Desktop app is we have hypervisor data and the views of this as well. Since we don't care what data is coming in, we don't actually, Splunk doesn't even know what data is coming in, you can start making correlations because most Zen Desktop environments will have a hypervisor layer in there somewhere and a storage layer in there somewhere, and all that stuff is in the index. Then we can make visualizations and correlations between that data because we don't care what's in the index.
And we could do it from, we're hypervisor agnostic, right? So we work with Zen Server, we work with Hyper-V, we work with vSphere. We haven't set it up, we can work with KVM. So we don't care about what's running the environment. We can collect data from all the sources, and we can integrate those. We can also do it to the storage, like I said. So we have NetApp and EMC, so we can collect data sets from there. So we can really kind of give you a holistic view all the way from the NetScaler all the way down to the storage of what's happening to a user. And to be clear, what I mean is I can find out for a specific user, like I put a user's name in, and find out what storage they're on, what hypervisor they're on, what virtual machine they're on, what NetScaler they're on, all that kind of good stuff. So I have a end-to-end picture of all the pieces and parts that this user's attached. We could also do that for web interface and other stuff. I haven't got to that just yet. We're building this as we go in regards to adding more functionality as we go. Understanding that this isn't app development, it's just really searches. We have all the data. It's just taking the time to build a search and then test the search and all that kind of good stuff. So this is what the Zen Desktop app by default looks like when you first open it up. It'll basically give you some basic statistics of what's going on, how many sessions you have going on, how many users are logged in, how many virtual machines are being used. This is a chart to show you all your desktop groups. You know how many desktop groups are in usage. You know how many are in use percentage-wise, how many are disconnected, connected, and all that kind of good stuff. One thing to note is that we also, because of the way that we do the data and the way we deal with the data, we can support Zen Desktop 4 all the way up to Zen Desktop 5.6, all at the same time, same interface, same infrastructure. You don't have to rebuild anything. All you have to do is install the agent, put the right TA, and magic happens. So we support it all at the same time. Over here, we created, so in Splunk we have a concept of what they call an alert. An alert is just basically a search that I've written. We'll go back to our server load search. Like I have that search where I say, show me all the server loads. I could have said, show me all the events where server load is greater than 5,000, right? And then if that returns a result, I want to see an alert regarding that, right? I want to be alerted on that activity. Now you have several options. When you get an alert, you can tell it to send a text message. You can tell it to send another event to somewhere else. You can tell it to do a lot of different stuff. One of the things you can tell it to do is scripted input. So you can say, hey, when you see this, run this script. And then, which really means that you can tell it to do whatever you want it to do when an alert goes off. Because if I can write a script, I can do anything I want. So these we have, I really should have this off the top of my head. I think we have like 12 or 15 predefined alerts for memory, disk, CPU. We have memory for high ICA latency. We actually have an alert for low ICA bandwidth because we have an expectation of the bandwidth being a certain amount. We have an alert for Windows event log application crashes, that kind of stuff. So what this dashboard shows you is just a real quick. In the last 24-hour period, we've had crashes on 57 desktops. We've had 42 with high CPU consumption. we've had 114 people with high latency, low available, 44 with low available memory. This is kind of a stack chart to show you by desktop group how many sessions are starting over time. The idea here is that for every customer or company, this pattern is a little different because you have different usage cases. Sometimes it's like a 9 to 5 thing. Sometimes it's spikes in the middle of the day, and then there's typically a pattern that you get used to seeing. But the good news is that if the pattern changes, normally you notice it immediately. Like, all right, that's different. That's not right. Something's wrong. The usage either dropped really low or the usage jumped really high, and that's not typical. So something has happened that has caused this usage change, and then you can tell by time when that situation happened. And then again, this is just percentage over time, so you have a very easy. Except on ours where the data gen is flatlined. Yes, he did not write this data gen. Yes, sir. Oh, absolutely. So this is just XML. Oh yeah. So the question was, do we have any drill down or that kind of stuff on the dashboards? So if I click application hang, it'll go to basically another dashboard that I wrote. That allows you to say that's alert. In this particular case, it's alert specific for that alert. And the fact is you can make this anything you want. And this is where I want to emphasize the fact, because that's a great question. This is where I want to emphasize that this is just what we've done. But if you don't like that, like you don't want that click through to be this, you want it to click through to something else, you can go change that, right? It's not going to change the supportability. It's not going to change any of that stuff, right? You can change this to do whatever you want. But yeah, you can do click-throughs. You can tell it to show you the raw. Like a lot of reports, I have it actually just show you the raw data when you click it, so that you can see what generated that value. In this case, we wanted to give you a report that shows you overviews of that specific alert. So it's been fired because it only showed the alert 57 times on 57 virtual machines, but it actually fired 515 times. And then it can show you that it's happened for different applications at different times. So you can get more detail about that alert. So that was pretty much the session statistics. How are we doing on time, actually? Are you trying to do math? Okay. So this is session stuff. This is very similar to the first page. The big difference are these little charts here. This will tell me if I have any particular users that seem to be more using Zen Desktop more than others, if I'm getting access from a specific client IP more frequently than others, if I have a specific virtual machine that seems to be being used more often. These are the people like these ones down here. This is the top client version and top device type. And if you have more than one Zen Desktop broker, you can see if the load balancing is working properly, or if you're spreading out your load amongst your brokers that way. And including, again, if you have Zen Desktop like 6 or Zen Desktop 5 and Zen Desktop 4, you could see all of this data on the same sheet. Right? It's not like I have to have different dashboards for each product. Some reports I think are interesting. This isn't going to work for this one. It only works on the. Oh yeah. So desktop performance. If I want to just get an idea of what my performance is as a whole across my environment, I can do this. And it'll show you the top VMs, desktop groups, catalogs, and hosting servers by CPU, memory, and disk. All right. So like this top one is so it's basically the same graph, 3 different times, one for memory, one for disk, and one for CPU. This is the CPU one. It'll show you that these are the VMs that are doing the most CPU average. These are the desktop groups by order of CPU average. So this guy obviously seems to be a very busy guy. Yeah. In this case, these are the different catalogs. Those catalogs go together, so obviously that makes sense. And these are your hypervisors, hosting servers. This data, actually, to be clear, only populates if you're using Zen Desktop for your hypervisor management. Does that make sense? And Zen Desktop, you can say use hypervisor. You can tell it to import VMs from a hypervisor, where Zen Desktop will actually manage the hypervisor for you. If you set that up, this will be populated. If you don't set that up, it won't be populated. To that point, we don't necessarily need that functionality to do what we want to do. And we are actually going to have, so you have, we'll have the actual hypervisor data in here as well, regardless if you're using Zen Desktop or not.
Because we have a hypervisor application as well that's feeding data into indexes, so then you can do a correlation to the VM in which hypervisor it's running on, hypervisor agnostic, doesn't matter which one, and start drilling down into the hypervisor layer, into the storage of that, into the networking of that, and see what's going on out in your hypervisor itself.
I gotta remember which. So this is user experience. We basically went through, we looked at Citrix best practices, Microsoft best practices, to get some ideas of what values should be the defaults, and which values are acceptable, which values are not acceptable. And we created basically usability index. So in this case, we have a 1 is critical, 5 is info 1. And the reason why we went through and did that is because one thing we want to be able to do, one dashboard, or I should say it's actually going to be a set of dashboards, because I don't think you could do this in one. But what we want to do is be able to introduce capacity planning as well. We have all the data, and there's no reason why we can't. So we want to build a capacity planning dashboard built off of these numbers, so that you can say, I don't ever want to exceed, info 4 or info 2 or info 1, whatever the value is on my VMs. Given that, and given the number of VMs I have now versus the hypervisors I have now, how much growth do I have, and when should I have to buy more hypervisors, that kind of stuff. We could easily add that kind of logic, because we've broken down the components into different, and they're weighted differently. So IOPS obviously are higher in virtualization. They're a higher value than CPU or memory. So we weight them that way. Anyway, so this is the user experience. This is the page. Right now the page looks different than I really want it to end up looking. I want to have a user experience page. So ideally, we'll have 2 versions of this. One will be a detailed version, and one will be just an overview. And the overview, I really want to be what I had said earlier, where it's you put in the user's name, and it's just a bunch of green, yellow, and red lights for each one of the components, just to see where do I go to, what part is broke. And that's where we would have a click-through, where you click it, and then you would go into a detail. Okay, this is yellow, why is it yellow? And go through and get you more details about why it's yellow. And then you can actually click into that to get into the data from there. So we have ICA statistics showing you what the bandwidth consumption is on average, what the latency is, as well as pretty line charts, because everyone likes line charts. Same thing with processor, memory, and disk transfers. And then at the bottom here, we have Windows event log data, and we have reports for if you want to see the applications that are installed, running processes. We'll click this in just a second, and BIOS information. And for simplicity's sake, I wanted to have, again, one place that you can go in, type a user's name, and get all the data you could possibly get. So this is basically all of the Zen Desktop 5 data for that user. The broker that they're on, the hypervisor, the client version they're using, the agent that they're connected to, all that kind of good stuff is in that little breakdown there. Protocol, receiver, all that kind of good stuff. Now this is a really useful report to show you over the last 24 hours, because that was the period that we had picked, the virtual machine that user's been on. It takes all the processes that were run and tells you what are the top 10 or 8 or whatever this is. looks like top something, of CPU consumers, CPU, memory, and disk, or network and disk. So you can see in this particular case that this guy right here seems to be a memory hog, significant memory hog. You can also see that IEE seems to be a CPU hog, which I don't think anyone's shocked by that. Explorer is taking a lot of CPU as well. If you look down here, the CCSV service is also consuming a lot of network or disk I/O, and Outlook is as well. So, and if you want a full report, you can click that, and that'll give you all the processes and all the data that they gave. So that is the effective. Oh, so the last thing I'll show you is the alerts. A lot of these things are very similar in the Zen app and the Zen Desktop, so we only need to have really one there. What this will do is this is a report of all the alerts that you have going on in whatever time period you have. So this is in the last 30 days. It'll show you all the alerts. This is alerts by severity, how many critical versus how many warnings that you had. It's apparently critical seems to be our biggest thing. This is alerts by type, so we can see all the different alerts that we had and the types that we had. This actually looks better on a screen that isn't compressed. But down here we have all the affected users, and we can see in this particular case the no user is the biggest. And that is because it is possible for a virtual machine that doesn't have a user assigned to have a CPU, memory, or disk problem. And in that case, there's no user assigned, so I can't associate that alert to a user. So we have an unassigned user in that case. Our top alerts, we have low memory. So high latency seems to be our biggest problem over the last 30 days at least, with application hanging being a pretty good second. Any questions on that?
So, were any of you guys in Dan Brinkman's session about how to fail at VDI? Yeah, a few. So one of the things that was brought up in there about how to fail at VDI is in the pilot phase, really collecting data and analyzing the data, and that's, if you don't do that, that's one of the ways that you fail at VDI. So a tool like Splunk can help you analyze in a pilot, or of course in a production environment as well. But to that point, in a pilot, Splunk, we do have a free download of Splunk. As Brandon already mentioned, Splunk is licensed on how much data you index in a given day. You go to Splunk.com, there's a free download. It's 500 megs of data a day, which is a pretty fair amount of data, considering that's mostly text data. And that will get you through a lot of proof of concepts, and even small to medium business. Some of them, you can just run on a 500 megabyte license a day, totally free forever.
All right, so two dashboards that I wanted to show you. Actually, I have it right here. The client device report. So this is one of the things we needed to be able to figure out pretty easily and pretty quickly, where all the clients types that were getting connected. So in this case, the different client versions, Mac, Windows, OS, iOS, Android, they not only are there different platforms, but each platform has a plethora of versions that could be used. As I'm sure if any of y'all have been in Citrix more than a month, know ICA clients get updated constantly, right? And as part of that process, the reason why they get updated is because someone found a bug, and you may have, one of these bugs may impact your environment. So being able to quickly determine how many people are using the old version versus how many people have upgraded, and seeing that rolling trend, it's very important information. Not only that, we also show you iOS device, the type of devices. We apparently don't use Windows. That's a telling story there. iOS, Android, and Mac seem to be our primary. Man, it looks like a peace sign. It's so even. Data gen for the loss.
I wrote that data gen, sorry.
Yeah. So Jason doesn't like Windows apparently. Anyway.
I do like Windows.
Yeah.
I forgot to put it in the data gen.
Anyway, the other one is Citrix licensing. So this is a dashboard to let you know how many Citrix licensing products that you have, how many users are consuming licenses, what the overall percentage of licensing is. We have a lot of licenses and only a few users, so obviously our percentage is very low. You can also see the license usage over time by product and percentage use of time over product. And then for those guys that really like to have the chart, you can do the chart down here. This will show you all the products that you have, the licensed, how many of those are in use, how many of the overall percentage, and how many you have available. Zen App session statistics look a little different. I love spark lines, so I use them all over the place. These are spark lines, which are basically just really itty-bitty graphs that you can put in a table to see the little dips. But they're useful because if you see this one says 25, you can look at the spark line and see that when the 25 happened. And this one it says 3, so it's got 3 little ones. You can see it. Some of you can probably see that. Some of you in the back 40 there can't. Any questions? Why don't you, you have the, oh, yay, I like questions. No. So, yeah. If you make customizations to the apps that we have and I send up an update, do you have to redo your changes? And the answer is no, and I'll show you why. So if you look at underneath the covers here to Splunk, you're looking at all my stuff, man. So remember I said that the apps are just a bunch of folders and stuff. Where's this book? So this is the Splunk for Zen app, right? This is what an app looks like. Again, no compiled code, no binary. It's just no install, just a bunch of folders. In this folder, we have what we call default, and we have local, right? So everything that I do is going to be done in default. And the way that it works with Splunk is it's a hierarchy. So the first thing it does when an app starts is it loads everything in default. If there's anything in local, it will then apply what's in local. So and that goes all the way from the base of the product itself. So Splunk has got a default and a local, like the application itself has got a Splunk and local. So if you want to do a local configuration change to Splunk, you would put that in local. You never change default. And then on top of that, you can do apps. So it's really just kind of filtering down the changes. So and that's really all, I mean, to be perfectly frank, that's all an app is a set of default configuration for Splunk that you've put it kind of packaged in an app and put outside of it. And this allows you kind of that other little thing. So you would put everything you wanted to do in local. Does that answer your question? Yeah?
Another question?
Yeah.
If I wanted to put this into a POC,
Uh-huh.
use a 500 megabyte license, what kind of infrastructure, how much effort do you think that's going to take?
The infrastructure for 500 megs is one server. And that could be a virtual machine. Huh?
I mean, because I've got users with 16 gig desktops, so, when you say a server, how big is a server?
Well, no, for 500 megs, you could put it on a virtual machine.
Yeah. 1 CPU, 2 CPUs?
I would probably do 2 CPUs. So, I mean, to give you scope, our standard recommendation for 100 gigs of data a day is a machine with, I think it's 4 processors at 2.8 gigahertz, 8 gigs of RAM, and 800 IOPS. And that can support 100 gigs of. So it's a commodity server, right? It's not. They're not like high end. I need a deal of 585 with, 290 gigs of RAM or anything like that. It's very commodity size hardware. The only issue with virtualization is that there's 2 things I tell people to try to steer away from with Splunk, and that's installing on Windows. And the only reason why I say that is because people tend to love to install stuff on Windows. So if you install Splunk on a Windows box, unless you say do not install something else on this Windows box, there's a high probability that someone is going to install something else on that Windows box. And just like everything else, Splunk works really, really well if you give it the resources that it requests, right? It doesn't want to have to fight for I/O. It doesn't want to have to fight for disk and CPU. I mean, it is a server product. It's meant to be by itself. Does that make sense? So same thing with a virtual machine. It works really well on a virtual machine if you actually give it the resources, right? You can't put it on a virtual machine and it's expecting 800 IOPS and you're giving it 10, right? It's not going to work very well. So just keep that in mind. Yes? I mean, you can do whatever. We don't sell it. We only give it as software, like just a software package. There are some customers. We do have some partners out there that will create Splunk appliances for you, and we do create. For some of our apps, we'll create what we call a virtual appliance, which is we've done all the configuration, put it in a virtual machine and said here. But you could do that, yes. So, and there actually may, like if you go on VMware, like if you go to VMware.com and look, there may actually be a Splunk virtual appliance. I haven't looked. It just needs specific resources. Yes.
You focus today on Zen App and Zen Desktop. Do you have apps for the other main players? VMware?
So, it's like a mom. The question was, we mentioned Zen App, Zen Desktop. Do we have anything for the other players? We're working on it, right? So I have a team of 3 guys, me, Jason, and one other guy, Hal Rottenberg. He's a V expert. So yes, we definitely want to have it. We have, Splunk, not necessarily my group, we do have a VMware solution for vSphere. Jason's actually working on a Splunk for server virtualization that's going to be a generic platform agnostic app, so that you can actually have Zen App or Zen Desktop, Zen Server, Hyper-V, VMware, and KVM, all using the same. So it's all they would send all their data to the index and have a single dashboard, because they have very common concepts: cluster, VM, that kind of stuff. Those concepts don't fluctuate differently. And then that app will have, for VMware, there'll be VMware specific dashboards, and there'll be Zen Server specific dashboards, so that you can, for most people, or like 80% of the people, that main dashboard's enough. But we looked at doing View, but to be frank, there's nobody using it. I mean, Gartner says it's about 50-50, but I think they're just talking about licenses sold. I don't think they're talking about actually licenses deployed. I haven't seen, we haven't had one customer yet that's come up and asked for View. But as soon as they do, as soon as the demand's there, it's not a hard thing to do. The infrastructure that I have already for Zen Server or Zen Desktop, it would be very easy to port over View. Zen App obviously is completely different. We're also doing OpenStack, CloudStack, Cloud Gateway. We're working on NetScaler, branch repeater, all of that stuff. So, yeah. We can. Yes, we have a data gen for it. It's not all exciting, but I can show it to you. It's probably actually our most mature of our Citrix apps. It's been around, I think, the longest. Did I just do that in the search? Oh, sorry, this is not the one I wanted. Sorry. This is the one in San Francisco. I don't. It's like creepy. Let me go. I got to do my local one. That's what I'm trying to do. So here's a. Actually, I was in the midst of building my NetScaler environment last week, so I could actually have some real data. But anyway, we have fake data, which is almost as good. I'm done? Oh. Apparently, no, you cannot see NetScaler. If anyone wants to come see it, they're kicking me out, apparently. Yeah, you can see the NetScaler stuff at the Splunk booth. We'll also have the Splunk for hypervisors, if you want to go look at that, or for server virtualization. Yes, one final question. No, it's awesome. It works actually. It works well in the United States. I know it's got some negative connotations here in the UK, but only if you drop the L. Outside of that, we're good.
Thanks, guys.
Yeah.